this computer. Alrighty. So, okay. So I hope you're all ready. And before we are going to start, so you need to install a number of packages. So the first package is called the tidyverse. Then you need the NHANUS, whatever it's pronounced, NHANUS, and cowplot. So these are the packages that you all need to install. And so again, just a reminder, right? If you're installing packages, you always have to put them in quotes, in quotation marks, and then when you're actually loading the packages, so you don't use the quotation marks. Right? So you may have some of them installed already on your machines, and you don't have to do it again. But just in case you haven't, then so please do it now. And so so the first part of our lab today is about the tidyverse. So tidyverse is a set of functions that are all about data frames. So and organizing data. So they're extremely powerful, extremely useful. And so they are similar to functionality that comes with the R-based system and that comes with a regular data frame. But so the tidyverse is so basically has its own version of a data frame. It's called a Tibble, and Tibble is just a more modern so data frame. Has a few features that are just more convenient, a little bit more up to date, right? So they tweaked the functionality a little bit, and it's almost everyone works with the tidyverse functions now, just because they're really great and intuitive. Okay, so and first of all, so we want to make a data frame, and we're using the function Tibble, right? So just Tibble, that's a function, comes with our tidyverse package. And so as you all know, data frames just a collection of variables, right? So each column of a data frame corresponds to a variable in statistical sense, not in the programming sense. And so the Tibble and tidyverse is nothing but a data frame, right? And so again, always think of like your Excel sheet or your SPSS data sheet, so which is basically the same. All right. So, and we can construct our Tibble either from data that is sitting in some text file that we first import to Excel, but here we will construct so an easy Tibble on our own. And we can simply do that by binding together different vectors. So each of our vectors corresponds to a variable. And let's assume here a very simple case so that we have four variables, so 4 different vectors. 2 are categorical vectors, so they have character, the data type is a character. 1 is a numeric vector, and 1 is a basically a response variable. So we have a logical vector, so it has true and false as values. Then let's assume, so that could be here our first vector or the names of different subjects. And then the second vector is the age. The third vector is what car they're driving. And the fourth vector is whether they're single or not. Right? So it's true, true, false, 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 true. We can also write 1, 1, 0, 1 if we want to. So it's basically the same. So that's how R interprets it anyway. But for, right, just to get a little more familiar with that, so let's just do it this way. And then, as I said, we can just take these 4 different vectors and we bind them together into a data frame, right? So into a nice data table. And we do that, so we basically create a new variable. So we call that variable myDataFrame, so myDF. And so we assign it, so the data frame that is created by this function call here, function called Tibble, right? So Tibble is a function name. And then the parentheses, you give it the arguments. And these are just our 4 vectors. And here you can put the vectors in any order that you want them to be in your data frame, right? So if you want to have the car in the first column, so then you have to start with car. If you want single as your first variable, so the first column in your data frame, you have to start with single, etc. So here you order them in the way you want them to be arranged. Okay. And then if you type in mydf, then what you're getting is this nice output here. And that tells you this is a tibble. So this is a data frame. These are the dimensions. So you have 4 rows and 4 columns. And then it tells you the names of the columns. So it's name, age, single, and car. And it's also nice and tells you what the type is. It's character, double, logical, and character. And then, so these are the row numbers here, right? So the 4 rows. And so then it tells you what the values are in your fields, right, of your tibble. And so you can also, if you basically just want to get an idea, if you have, for example, like some data set and just want to look at what it looks like, or what's in your data, if it looks reasonable, for example, after reading in your data from a text file. So you just want to take a look whether everything looks all right. So then you could use a function that is called glimpse. Yeah? So you just type in glimpse, and then you give it the name of your tibble that you want to look at. And then it gives you, so typically, when you have a bigger tibble or the bigger data frame with many values, it won't print out all of them. It just will print out the first, I don't know, whatever fits on your screen. You can also change that in settings. And so it will list all the variables that you have in your data frame, right? So, but here it's a small one, so we can, so R is able to print it all on the screen. So it tells you 4 rows, 4 columns. And then, right, so the first column is names, age, single, car, and then that gives you the type, basically the same information, just a little bit nicer organized. All right, so how can we select elements from our data frame? So one is always an R, so this is in each programming language. At the beginning can be a little bit confusing because there are always 1 million ways to do the same thing. Right? And eventually you have to decide what's the most convenient way to do it for you. It also sometimes depends on how the way your data is structured. For example, when I want to select element from my data frame, I can do that by name, right? I can do that by variable name of my column. I can do it by the index position, right? So whether I want the first, the second, the fourth, or whatever. And it sometimes depends on, as I said, so how your data look like and what's most convenient for you. Whether it's more convenient to choose the numerical indexing or the indexing by name. Right? So it's also, it always depends on what information you have available. Right? So sometimes you simply don't know what's a number, what number your column, the variable. So then it's easier to access it by name. Anyway, so you can select the elements from a data frame by names using the $ operator. Right? So that works also with regular. So many things also work with regular data frames, not only with a tidyverse. So this is a little bit. So you have you have to be careful. So there's also different functions that come from different packages. So and sometimes you have to specify what function you're actually referring to. So they are sometimes masked. Right, so if you, for example, load the tidyverse package, and maybe R will tell you, so it's masking like different functions from other packages. So it's whenever you call a function, so then it will be from, right, from for example, in this case, from the tidyverse package. But if you want it from another package, you have to explicitly tell R that it's supposed to come from this package. And so you do that by basically so in front of the function name, you put the package name, and then you have 2 colons, and then and then the function name, right? So package name, 2 colons, function name, and that's basically force R to use this function from a certain package. Yeah. Okay, so that is just a side note. All right, so let's assume we want the variable car. So then we just say mydf $car. And R gives us the car variable, right? So or column. We can also select elements by index, right? As I already said, and then we have to use these square brackets here. And so it doesn't have to be one, right? So we can select multiple columns at once. And so here in this case, so I'm selecting a certain element. So the first index here is a row. The second index is the column. So that is basically the value that is in the second row, and so in the third column. And that is true, right? It's from our single, sorry, from our single variable, right? So second row, third column. So this is true here. Okay, and so again, so the answer is a tibble, right? It's another data frame that you get when you call this, when you index elements that way. Okay, so if you would like to select an entire column or row using the indexing, so again, you have different options, but the least confusing way to do that, in my opinion, is here, if you want to select an entire row, in this case would be the second row, you tell R, so what row you want, and then you just leave the column empty, right? And then R knows you want the entire thing. Yeah, so in here, you get your second row, right? In this case was Berta. Yeah, you get the entire Berta row here. So you can do the same thing if you want to access a certain column. So if you want the fourth column, you just leave the row open. So then R knows you want all rows and the fourth column, so the entire fourth column, right? And here you get the car vector, so your variable car. As I said, so you can always select multiple columns or rows, and then again, there are 1 million ways to do it. Always depends on what you want to accomplish. So you will have noticed, so also when you read the, especially if you read the R cookbook already, so that this nice colon operator, you can read that as 2, right? So here it just means 1, 2, 2. So you want basically rows 1 to 2. You could also say 1 to 3 or 1 to 4, whatever meets your needs, and then R will just give you so rows 1 to 2 and all corresponding columns, right? So the entire rows here, which is Adam and Berta, so our first 2 ones. And yeah, of course, you can also do that for the columns. And so if you want them to basically, if you want the output to be in reversed order, you can also say something like that, right? So I want all rows, and then I want columns 4 to 2. So then, so I will give you 4, 3, 2, right? In that order. So you get car, single, age. Yeah, if you want to reverse the order. And you can also do like all sorts of crazy things, right? You can, okay. So you can, if you want only the first and the third, right? So you can tell R. Then don't forget, if you if basically this is if you don't use the colon operator here, you have to use the C function, right, to make it a vector, to tell R that this is a vector, right? So you always have to put the C and in the parentheses your indices here, otherwise R doesn't know what to do, right? So it won't give you an error message. Okay, so here you get 1 and 3. You could also say 3 and 1 if you want 3 first. No? I hope that makes sense. Okay, so and these are all very general operations that work with basically any data frame, right? It doesn't have to be a tibble. And so, and then, so tidyverse has a few functions that are, as I said, so they're very nice and a bit convenient, so that are special to the tidyverse. And one of them is slice. So slice simply allows you to select rows based on the numbers, right? Just a different way of doing it. And so here, again, you use the my data frame, and then you say slice 1 and 4. So that means just give me rows 1 and 4. And so you will have noticed that, so here is this weird operator, which is called a pipe. So you also might be familiar with the pipe from the R cookbook already, hopefully. So pipe is also very, very useful. It makes, so a bit confusing maybe at first, but it makes code much more readable and much better organized. So basically it is just a concatenation. So a combination of different functions, like in a sequence of functions. And the way it's structured is that you have on the left side of your pipe operator, you always have an object. So that can be either like here, a variable, so data frame. It can also be another function. But so let's make it a little bit easier. So let's say, so we have a variable here on the left side. And on the right side of the other side of your pipe operator, you always have a function. And then what the pipe does, it just gives this function here on the right side, whatever you have on the left side, this object on the left side is an argument. And it's always the first argument. Yeah, so that's what it's doing. So basically what you're doing here is you're calling slice with the function mydf as the first argument, with the data frame, the tibble mydf as a first argument, and then 1 and 4, so these two rows as a second argument. Yeah. So and basically, so that is just an explanation what the pipe does, right? So when we write mydf and then pipe operator slice 1, 2, it's the same as if we would write slice mydf, so that is the first argument, right? So our data frame, and then the vector 1 and 4, so the vector of the rows that we want to select. So that is the same. And I'm not sure whether you will agree with me, but that is easier to read. So if you get familiar with the pipe operator, it is much easier for you to read that piece of code, right? So pulling it apart. Okay. So we will get back to that. So it sometimes can be a little bit annoying because you don't always want the object on the left side to be actually the first argument, but there are ways to avoid that. But we'll have an example later. So you can put it in all sorts of positions in the argument list of the later function codes. Okay. So you can also select rows and columns based on specific values, right? So based on what's actually not only by their name or by their position, but you can also say, I want to select my data based on what's actually in there. So what values are in my rows or in my columns. And again, so there are several ways to do that. So one very useful function is called filter. Yeah, and so this filter function will only retain rows that meet your stated criteria. Yeah, so we have here one example. So you can see again, we're using our nice pipe operator, and so we're doing something else. I'll tell you in a second. So let's for now, let's just focus. So again, we have mydf, so our tibble on the left side. And then, so here on the right side, we are calling the filter function, and we specify our criterion here in the parentheses, right? That's our argument. And we say names equals Berta. So that means please select only so the rows where so the value for name is Berta. Yes, I mean, we know we have only one Berta. But if we had like 3 Bertas in our data frame, then so it would select all rows where the name has value Berta. So another thing that I just wanted to, I'm always basically including here in this tutorial, like certain things that I want you to pay attention to. So what we are doing different here, and in the previous examples, we're actually assigning the output of this expression here to a new variable, which in this case I call mydf filled. So on all these examples above, so these operations were not saved, right? So basically are just printed, so the output in the console, but it did not actually change mydf. So you did not actually change the tibble. Tibble stays unchanged, and you also didn't save the outcome of this operation, of this command, right? If you want that to happen, if you actually want to keep so in this case as a filtered output, then you have to assign that to a new variable, which we are doing right here, right? And then if you type mydf filled, so then it will give you so this row where the value for name is Berta. Okay. So there are no limits. You can filter as many criteria at once as you would like to. So don't have to limit yourself to only one. So you could, for example, say, so please give me all rows where the name is either Berta or Dora. Yeah. So yeah, go ahead.
I was gonna say, I'm having a very difficult time just getting this thing to install properly. I keep getting warning, error, warning, and even when I type it in, like it's just not happening. like, is there any other way that I could install this so that way it should be easy. I know how to install. It says install there, I type it in and stuff, but or I copy and paste, but it's just not happening.
Yeah. What are you trying to install, the packages, or what doesn't work?
The packages so that way I could continue on with you, but it keeps saying warning. And this version of the package of R might be available somewhere else. And yeah, and I tried doing it one at a time, and each time it keeps saying error
So for which one? For all of them?
for all of them. Yeah.
When you say install packages tidyverse, it says it's not available.
Yeah.
And you have your internet connection works.
Yeah.
Really?
I mean, half of my apartment is running without power because there's like a whole power outage right now.
Yeah.
But I'm good in my room. I like
Okay.
installed something to like work. I don't know.
Hmm.
Oh,
Okay, so yeah, I'm sorry. So maybe it would have been smart actually. So I realized, sorry, I should have let you know so that before our lab exercises, that I let you know ahead of time what packages we actually need. So it's
okay.
and then I keep forgetting because I have everything installed already. So it's just loads of libraries. But if you, yeah, sometimes there. Did anyone else have issues installing the packages?
Yeah, it's telling me that I would need R tools, which I'm currently downloading now,
Okay.
and maybe something about a library error, but I might have to reconfigure installation paths. I'm not sure yet.
Alrighty, yeah, sorry about that. So moving forward, what I'm going to do is I will let you know before the lab, so ahead of time. So try at the latest by end of Sunday, what packages we are going to use so that you can make sure you have them all installed so that we don't have like annoying problems with it. Sorry about that. No, my bad. Should have done that. Was not very bright.
It's okay.
Yeah. So yeah, then hopefully, so you can just try to mentally follow and then later implement it, hopefully. Okay, so alrighty, where did we stop here? Right. So as I said, so you can specify as many criteria as you wish, yeah, as long as much as it makes sense to you. And so this is our right. So this is the operator for or, for a logical or. And that, don't forget, we learned about that, right? It means not either or. It means right. It could also be both, right? Just as a reminder. So it's a logical or. So it's either Berta or Dora or Berta and Dora, which in this case is not possible, but just keep that in mind. Okay, so there's also a way, right? So this was so to filter certain rows, so to select certain rows, we can also select columns based on their name using a special function that's called select, also a special tidyverse function. And so, so we can do that based on their names or based on their indices. So which number they are in the data frame. So and if we wanted to do that by name, we can use the same operators that we are also using for the indices, for the numeric indices, right? We could say H2 single. That's are absolutely happy and fine with that. So and then it will give us the two last columns here. And so we could do the same thing if you, for example, wanted to select so the second and the fourth, right? We can also tell R, so give me so the second and the fourth. Alrighty, so that is not using the select function, right? So this is using the so the direct indexing. Okay, so we can use very much the same functions, the same ways of accessing elements to also remove them from a data frame, from a tibble. And the way R does the removing thing is mostly just by using negative indices. So basically, whenever you want to remove something, you put a minus in front of it. Right, so using almost the same syntax as for just simply accessing the elements, but you put a minus before. So let's assume we want to remove a range of columns. Yeah, so then we say, so we again we define so one argument, it's mydf. I'm using our pipe operator again, and say select, right, from my, so my, again, as I remember, mydf is the first argument here in this for this function call. And then so rather than pulling so these columns out of our data frame, we are subtracting them, so to say. Yeah. So just by putting this little minus sign in front of them. So you see that the syntax, the grammar is exactly the same here. Right, and then what we get is just so the tibble, the data frame with car, 2 single columns removed. So that leaves us with names and age. We can also remove a column by position, so by their numerical index. Yeah, so this is if we wanted to remove the second column, we just say -2. Yeah, again, always keep in mind that the function select in itself also wants, of course, the data frame, but we are piping so basically we're piping that in here, right? So that's why we don't have to put it as an argument in the parentheses for select. So here we have just removed the second column, which was age. So you can even be fancier. So that if you look up the documentation, which I always recommend, right? So if you're going over tutorials or if you're using some functions in your own code, in your own programming, so always look up the documentation, in this case for select, and then check what it can do, right? So what the arguments are, what it means. So R is very good. The documentation explains everything. And you can do all sorts of fancy things with select. So here you could remove columns that contain the letter A, right? So you just say minus contains A, and then it will leave you just with single because all other columns contain the letter A in their names. And as I said, so this is just the tip of the iceberg. So whatever selection needs you have, you will most likely find so something that meets these needs. So in order to remove a range of rows, you again use your slice function, the same that we just introduced when we're talking about how to select rows, with negative indexing. Yeah, so you just say slice and then -2 to 3, and it will just remove them. So the second to third row from your data, and just leaves you with the first and the fourth. Yeah, and you can always do it with numerical indexing if you want to, but it's just if you use the so the functions is again, it's often easier to read the code later on, so it just looks a little bit nicer. But it's basically your prep. So whatever you prefer, what you like. So if you want to remove the fourth column, right? So you can also use your square bracket indexing. So right. So so we leave that empty here. That means all rows, and then we are moving the fourth column. And here, right. So we're removing the second row, and again, of course, all columns. So what you can also, or another thing that you can do if you want to really permanently remove certain columns or rows from your data frame, you can, and if you don't want to define a new variable and keeps the old data frame, so you can just set that column to null. And null is a reserved word in R and represents a null object. And if we wanted to delete the column car of our data frame, and if we would say, so here, what I'm doing here is I'm just saving our original data frame to like a variable that is called mydf org, because I want to conserve it. And then we can delete the column car by setting, right? So simply, so here I'm selecting it with the as a dollar operator. So I say column, right? So please column car, set that to null. And if you call myDF or data frame after doing that, you'll see that car really disappeared. So in this case, we have changed the so the underlying object. So I can also do that, right? So with indexing, right? So here I'm removing the third. And so, or by doing it for a whole set of columns, right? So again, so specifying all columns in a vector here. And so just if you want to do that, so you cannot just simply say null, because it's a null object. This only works for one column. So you have to define a null list. We will talk about lists later in the semester. So right now, I don't want you to get too confused. So we are focusing on data frames only. So later we will also talk about lists, which are similar, but more general. Okay, so just for the sake of completeness, right? If you want to do that for multiple columns at once, you have to say a list null. You have to add a null list. Okay, and then we basically have an empty data frame. So, okay, so and then following the same logic, we can also add elements to our data frame. And we will first, so before we add something, we will define two, so one thing to add, so one row to add and one column to add. And so if we want to add a row, of course, so that also has to be a data frame, and it has to have the same structure, the same variables as our existing data frame. So in this case, so we are just defining a new tibble here that has the same variables, right? So names, age, current single with new values. And so in order to add a new variable, a new column, we just need a vector. And that could be any vector, but it has to have the same length, so it's the same number, basically, right? It has to correspond to the number of rows of our existing data frame. Okay, so if we now want to add our new rows to our existing MyData frame, then we can use a function bind rows. Of course, we are not adding it to MyDF because it's empty now, but to MyDF org, right? That it's our original tibble that we have saved or assigned to this new variable. Okay. So what we want to do is we want to add this Zach tibble, which is basically a new row, to our existing tibble MyDF org. So we can do that using the bind rows function. So actually the base R system has something that's called rbind, so similar function, similar functionality, but it has a different name. Right? So, but if you're using the tidyverse, so you use bind rows. And then so again, our pipe operator here, right? So which means that bind rows, of course, also wants the tibble that we want to append to. And then we tell our what is the tibble that we want to attach, and we don't have to limit that to one row, right? So it can be any dimensionality. So as long as the number of columns is the same, so we can also add something that has 1,000 new rows. That doesn't matter. So I just don't want to type that much here. Okay. So if we do that, right, if we type in that command, then we'll see that our, the resulting value has now a new row, the Zach row here. And adding a new column is equally simple. So we can use the dollar operator again. We just specify the name that we want to assign to the new column, to the new variable in our tibble or data frame. And so in this case, I call it town. So that will result in so a new column called town. And in this case, at the end of the data frame. And so what I want to go into this basically new variable is what I have defined here as the vector hometown. Yeah, and if we do that, then we'll see that we now have a new column. And this column is called town, right? And it is inserted at the end of our existing tibble and ever existing data frame. And we can, as I said that before, right? So we can only add vectors that have the same length as the existing data frame. So I couldn't, if I would try to add something that has 6 elements here, so then I would complain and say that the dimensionality is not the same. So we have to be careful. All right. I'm just basically trying to, it's a bit nonsense, right? It doesn't make sense from a data processing point of view, but I just want to show you a few functions. So, which can be very useful when you're programming to generate certain vectors are the functions sec and rep. So that we will use rep for the next example. And what we are doing, basically this example is just to show you how these two functions work. So I will now generate a sequence of numbers that has equally spaced out values between 1 and 10, and is of the same length as my data frame. So basically, so I will call that new variable sequence here, right? So I add that to my data frame, so a new variable called sequence. And then I call this sec or seq function here and say, okay, so that is my basically the starting index. So this is, so I want values between 1 and 10. And so with that length out argument here, I tell R how long this sequence is supposed to be, and in this case, I want it to be as long as my existing tibble, and so the length of my existing to determine the length of my existing tibble. Of course, I could just say type 4 because in this case I know it and it's very easy. But in most cases, you don't know how long, and you also have like, right? You don't want to type in like a constant because it could change, makes your code extremely inflexible. So you want to read that value directly from your data. That's what you want to do when you're programming anyway. So using a function that is called dim, and so the function dim, if you just apply that to your tibble, it will typically give you so for this tibble, it will give you 2 values, right? So one for the number of rows and one for the number of columns. And so we want the number of rows, and that is the first of these 2, right? Is the first of these 2 values. So it always gives you the output is number of rows, number of columns of this dim function, so the dimension function. So we want the first index. That's why we say here, this is nothing but a vector, this whole thing here. And we want the first element from this vector, which is just the number of rows in our my.df.org tibble, right? And that's how long we want our sequence to be. So it sounds very complicated, right? It's actually pretty easy. And so the seq function, as I said, is extremely handy, extremely useful if you're trying to generate like long vectors or certain patterns, right? So pattern vectors. And you can see that's really nice, right? So it gives you equally, so with this argument, it gives you equally spaced values between 1 and 10, right? So it's always 3 in between. 1 plus 3 is 4, plus 3 is 7, plus 3 is 10. Super. Okay, as I said, so not very meaningful, just to show you, to demonstrate how these functions work. And so we can also add a new column using our square brackets, right? We could say my.df.org and then in quotes the name of the new column. So as I said, there are always like 1 million ways to do things in R. Sure. Since you're starting, I would recommend just pick one that you like, that seems reasonable to you and that you feel you can memorize, and then stick with it until you get a little bit more comfortable with R, and then you can diversify. So as I said, so another really useful function to create those pattern vectors is the wrap function. And that's just, so basically you're specifying some basic patterns, so some basic vector here. Just say it's a vector that contains 5 and 7, just 2 elements. And then I tell it here how many times do I want to repeat that, right? So I could say 100 times, and then I will get a vector that has 200 elements. It's 5, 7, 5, 7, 5, 7, 5, 7, 100 times. So here we want it only 2 times because that's the length of our, the size of our tibble. So that's the number of rows, right? So that will, this call here, this function call will create a vector with 4 elements, 5, 7, 5, 7. And if I add that, right, so to my df org as a new column that is called new column, then we see, right, so here we have 5, 7, 5, 7. So super, okay. So we can also create a new column using the add column function that comes with the tidyverse, and it's very intuitive. So here I say add column, please name it another column. So that's my column name. And so this column is just the values 1 to 4. It's just the values 1 to 4. It's just a vector 1, 2, 3, 4. So right, add that here. So the nice thing about so these special functions that come with a tidyverse is that, as I said, they are extremely versatile. So you can do all sorts of things. For example, if you don't want to add the column at the end of your existing data frame or tibble, but if you want to add them in a certain position, you just use the extra argument after, and you say, okay, please insert it after car. Yeah, and then it will, so here I say, add a new column, call it column after. So, and that's another interesting feature, right? So that is something that R does automatically. So you should protest here and say, wait, this is not a vector, that is only 1 element. So why is R not complaining? So, so this is something that R does automatically for you. If you give it just one single value, it will simply replicate it as often as you as it needs to, right? So if you would give it a wrong, so basically in a vector that has wrong dimension, it would complain. But if it's too small, then it will just do the autocomplete, right? And you say, okay, this column after that has basically all values are after in this column. So please insert it after car. So then we have here our new column called column after, has all after as values, and it's where we want it to be. So extremely useful. Saves you a lot of headache. Okay, and you can also add multiple columns at once, right? So you can just add column, and then you can add the columns with comma, right? So you can add a whole list of columns. Alrighty. So then we are not at the end, right? So often you want to add columns based on other columns. So you want to add a column. So in the values, this new column are actually some conditional on values in other in existing columns and other columns in the data frame, where you want to do some calculation. And so in order to do that, you can either use some functionality within the add column call, so it's in the add column function itself, or you could use something called mutate, which we will talk about, another function called mutate, which we'll talk about here. But let's talk about the first option first. So let's assume I want to add a new column to my tibble. And so here, call it new column, doesn't matter, right? So, and I want to have this new column, the value 100, if, so the, okay, I have to check what I did here. Okay, if the value for, this names in car, okay, if my Aha, all right. So I want it to be 100 if my name starts with the same character as the car, right? So when so the value for the variable name starts with the same character as the value for the variable car, then I want it to be 100. And if it's not the case, then I want it to be 200. Yeah, so we can do that. It's actually not hard. So basically what we're doing here, so we are constructing our new column that we call new column 1. So again, just arbitrary, right? So you can give it whatever name you want. And then we are calling a function if else. And this if else function basically just defines, so what is the value, what is a new value if whatever I put in here is true, and what is a new value if like a certain condition is false, right? So the first argument is always the condition, and then you put in here to the third as a second argument is a value if true, and the third argument is a value of false. So and what am I doing here? So here I am basically implementing the thing that I just told you. I'm comparing the first character of the name's value and the first character of the car's value. Yeah, and this is done using the function substring. And so substring for variable name and for the variable car. And so what you see here, I mean, that is familiar, right? So this is just a regular way of accessing, so it's a dollar operator of accessing these variables within the data frame. But this dot is a little bit unusual. And now, you remember that I said initially when we're using the pipe, then it's automatically piping this expression here. So on the left side, this object on the left side as a first argument to the next function. And I said we do not always want that. Well, this is an example where we don't want that. We want it to be somewhere else, right? We don't want it to be the first argument. We want it somewhere in the middle, and then we want it to be there again. And this is done by the dot. So the dot is here just a placeholder, and it basically indicates where we want. So where do we want this argument that we are piping into this function call here, right? So we basically, you can, wherever you see the dot, so we want the mydf.org. Now this is just a way to, right, to put the, when we're using the pipe operator, to put the argument on the left side in a different position as a function call on the right side. Okay, I know that is a little bit complex. So if you don't fully understand it, don't get too nervous. So but try. Try. I hope it's at least to understand the fundamental logic of so this expression. So if you have difficulties, so I'm happy to go over it later, or like some in a private conversation. Okay. So as I said, we can also compute or specify a new column, so the value of a new column using the function mutate. And so this is basically what you know from SPSS as a transform, right? Or so this data, all these data transformation operations. So let's say you wanted to add a new variable, so that is just age times 10 again, right? So my example is always nonsensical, just want to proof of principle. So let's assume I want to define a new variable, and this new variable is just happens to be so 10 times the age. So what I'm doing then is I call the mutate function, right? And I say, so please, calculate a new variable, call this new variable age 10. And this is how you calculate it. So you calculate how you compute the values. So please take variable age and multiply it by 10, right? And then what R will do is to give you this new variable here, right? So just 510, 320, 330, and 490. All right, you're almost done with this tidyverse. You can move on to fantastic ggplot, which is even worse. And okay, So this is just a little bit a little bit of an introduction how to use tidyverse to explore your data. This is really just some very basics, some very basic information. We will talk about more in-depth data screening and data quality check in our lab next week when we are actually doing the whole data screening part. So, and we're using this data set that comes with with R. And so that is just data that are collected by the CDC. And you can think of those data as a random sample of so all sorts of variables that are measured in a random sample of US residents. So each individual in this data set has a unique identifier. That identifier is stored in the variable ID. And so if you just want to get an idea of how large this data set is, so we can check how many rows it has, right? So how many basically cases we have in the data set, and that we can do using the function nrows, nrow, and we just give it, so this data set here is the input. And so then it tells you, oh, these are 10,000, so quite a lot. But so there is something not very desirable with this data set. So it has basically duplications of IDs. So they're like, it's not that each case, each subject or each individual has only one row. So sometimes you have duplicates. And so that is not nice, right? So you don't want to have like multiple rows for the same subject. So if you want to eliminate these double occurrences, we can use another nice function that is called unique. And so the unique function simply returns a vector that contains all the unique values for a particular variable. Yeah. And if we basically, so if you call unique, right? So this, the vector ID as the argument, as its argument, right? So we basically pull out ID from our NHANES data set. And then we ask, so how many unique IDs do we have? So then we'll get this vector, and then we are asking what is the length of this vector here. And then it's 6,779. So quite a few duplicates here. So we have only that many unique IDs. Okay. So we don't want that. So let's get rid of the duplicates. So we only want unique IDs. And so we want to save them a new data set, and let's call that data set NHANES unique. Okay. So, and of course, so the tidyverse has a nice function that helps us doing that. This function is called distinct. So, and so we will, so again, right, this is our new data frame here that we want to create. Well, it has only unique cases, so unique IDs, so no duplicates. And so we assign that, so the output from the function distinct. And distinct is supposed to operate based on the ID, right? So we want to eliminate all double, triple, whatever IDs. But we want to keep all variables in the data set, right? So basically you just want to exclude the rows where we have like, right, so the same ID, but we want to keep all the other variables in the data set. And if we do that, if we calculate this new data set and take a look at it, so then you can see, right, it is, so using this glimpse function again, so you can see we have the 6,779 rows, not surprising. We have 76 columns, so 76 variables, and they're all listed here, right? And then there's, of course, the ID, and then the survey year, gender, age, blah, 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 blah. So all sorts of things that were assessed in this survey. So in what I mentioned earlier is, right, so if you have like a huge data set, then so the glimpse function will print only the first few values. Yeah. Okay, so if we would have set the keep all, which is a default, if we would have set the keep all argument to false, which is a default, then we would have had only ID left, right? So nothing else. No, that's not what we want, right? So we want also variables here. Okay, so so as I said, so our data frame here has like 76 variables, right? We are not interested in all of them, and often we are not when we're doing some analysis. So we usually want to use only subset or even single variables. And so if we want to look at those individual variables, we can use the function, so another function that is convenient. And this function is called pull. So the pull function is actually very similar to the dollar operator, just looks a little bit nicer, especially when you're using it in pipe. So there's a pipe operator. So then the dollar can sometimes look a little weird and makes a code hard to read. So that's why it's nicer to have so the pull function, but it's basically doing a very similar thing. So it pulls out a certain variable or set of variables from your data frame. So let's just assume for now we want to extract the variable age from our data frame, right? So just a variable age, so we want to pull that out here. And so in order to do so, we are so using our pull function, right? So we are piping the data frame into so pull. We say we want age, right? So again, just a reminder, what this basically, so there's a pipe command here. What we are saying here is pull n heinous, or don't really know how to pronounce and how to spell that. How to pronounce this the name of this data set. So basically always think, yeah, this here is the first argument for the pull function here. So if we pull age out of this data set, and then the result, right, of this expression here, so that is basically the column, the variable age from the data set, this is piped into this function. Yeah, so what we want is the head, so the first 10 elements of this vector, right? So what this here is doing is just pulling out the age variable, so that means it's one vector from this bigger data set, and from this vector we want the first 10 elements, and that is right. So that's a function head that gives us a certain number, so here 10 of a vector that we give that function, right? And so if we do that, we will get the first 10 values of age, and that hopefully will correspond to what we have here, right, in our data frame. Okay, and then we can do things like computing a frequency distribution, right? So always nice to do things by hand on your own, right? That we learned in theory and in class, and now we can do it in our, will deepen our understanding. Okay, so let's assume we would like to compute a frequency distribution that shows us how many people are feeling depressed on none of the days, several days, or most of the days over the past 2 weeks. And that is based on the variable depressed. Yeah, so let's go back here. You can see that we have a variable that is called depressed. And so the question that corresponded to the variable, so in the past 2 weeks, on how many days did you feel like not very happy? And then it was like several, none, most. And so these NAs here are missing values, right? So where we don't have, so either because the person did not answer the question or it was not part of this survey. So it's a combination of different things. So, okay. And so again, we will break that down here. It's a relatively long expression, relatively long command, but it shows the power of the pipe operator. So otherwise, that would be absolutely unreadable code if we wanted to put that in one single expression without the pipe operator, or we would have to break it down into like different sub-steps where we always have to save like a temporary variable as a result of the previous operation. Okay, so let's go through that step by step. So what are we going to do? So we are defining a new data frame here, and we call this data frame depressed, df. It's our new data frame. And this is just the, right, so this is a new variable, and then we are assigning it a value that is defined by this whole expression here, right? So next to the assignment operator. Okay, so what are we going to do? So first, we are specifying the first argument to the pipe operators, or first argument. We're piping that argument into the mutate function. So the mutate function here is doing nothing but so giving the let's go back to the depressed variable here. So I mentioned that there are several cases that have missing values. So because I didn't answer the question for whatever reason, right? And so the way R treats these NAs, these missing values, is not good for several functions, like for example plotting and creating frequency tables. So because the NA, for example, is not listed as a factor level, so we either would have to exclude those missing values first, or we have to deal with them in a certain way. And so we may not want to exclude them, right? Because that will effectively reduce our sample size and also change all the metrics, all the statistics that we are computing from it. So, and what we are doing here is we are making these implicit NAs, so these implicit missing values, just into an explicit value. So it's basically just treated like any other factor level of the factor depressed. Yeah, so it's basically the same value. It has the same status as none or several or most. Yeah, so it's this additional category missing. Yeah, so we define that really as a level of our factor. Okay. And that is done by this function here. So explicit NA, right? So we tell depressed. And that's what we're going to do, right? So we are recalculating the variable depressed and converting the implicit system, so misses, so these implicit values into explicit, some explicit missing value. All right, so then right, then we have another pipe operator. Now we are taking, right, so this transformed data frame and putting it into our next step. So, and what we are doing here. So now we are selecting, so the variable depressed. So we're just pulling out the variable, so depressed from our data frame. That will be the input for our next operation. Now here it says group by. So the group by function is simply organizing so the data into like different groups. And what it does is, so that the group variable has to be a categorical variable. So what it does is that basically if you define this group structure, then all following operations will be performed at a group level. So here we basically want all the following operations to be performed separately for the different values in depressed, right? So we want, so the operation, so in this case, we are just summarizing, so we're just counting values, but we want to do that separately for the missing values, for the people who responded none, for the people who responded several, for the people who responded most. Yeah, so this is our, basically we have these different groups and we want to calculate, so we want to perform operations separately. It's like you can think of it as you now have 4 different data sets, right? So the data set for misses, the data set for sums, the data set for none, this is the data set for several or 5 data sets, and for most. And whatever you do next is basically performed within these smaller sub data sets. Okay. All right, so what are we going to do? We are now summarizing so the data. So the summarize command creates a new data frame. And because there was this group call before we call summarize, so that data frame will contain the group variable, the grouping variable, and it will contain so a summary function per group for whatever we tell it to do here. And we say, okay, we want a new variable that is called absolute frequency. And this absolute frequency is just the number of cases, right? And right, and that is done separately for each of the groups that we have defined here. So it sounds very complicated. It's super easy. What we're asking R to do here is just count how many cases are missing for the depressed, based on the depressed variable, right? Based on the values of depressed. How many are missing? How many say none? How many say several? How many say most? So that's basically what we're doing here. Whew. Okay, and then so the cable function just prints the table in a prettier way. So let's just makes it like a nicer format. And that's what we're getting here, right? So we have, as I said, so a new data frame. So that our depressed DF here is a new data frame. It has the grouping variable, right, which is depressed with the different categories, none, several, most, missing. And then we have our statistic that we calculated, just the absolute frequencies, right? So it's 3,309 cases that said none, 677 said several, 286 said most days, and then we have 2,507 cases where we don't have an answer to this question. Alrighty. So, and if we now wanted to, right, because these are the raw counts, so if we wanted to calculate the relative frequencies and as a percentage value, so it's very easy to do. We just calculate a new column using the mutate function. And this new column is called percentage. And it's just the values of absolute frequency. So, right, of our variable absolute frequency, I have that here, divided by the sum of absolute frequencies. Yeah, so the sum over all categories, so the total sum over 6,700, I don't know what, 79, and multiplied by 100. Yeah, so then we have the percentage of people who say they didn't feel depressed on any day, etc., etc. Okay, so this was a tidyverse. And as I said earlier, if you want to learn how to read the text files from R, so please look into the R cookbook. Are you still alive? Then I would like to move on to plotting.
No, I died like a second ago, but it's okay. It's okay. Got it to download, so it's okay.
Alrighty, so you will probably, I mean, that is simply the way it works, right? So that's why it's time consuming. So and that's why I thought it's nice for you to have like a tutorial style document. So basically that you go yourself over this code again and try. And what's very, very important is, so you have to experiment a lot, right? If you're trying something, change the code. So try for example, try to change it to so change for example here what happens if I type in head 20. I mean, it's pretty simple, right? But so just try to manipulate a little bit, to change small things and see how the output, how the behavior is changing. Then you understand what it's actually doing. So you might get an error message because it, right? So that will help you to really internalize how it works and what the code is doing. All right, so let's talk about plotting. And I feel bad because ggplot is really it's always I'm always on the fence about it, because on the one hand you really need it if you use with R, because it's making fantastic plots, so fantastic, so you can visualize your there are almost no limits in the way you can visualize your data using ggplot, the ggplot package. And it's so there are plotting functions that come with the R base package, but they're a joke compared to ggplot. ggplot, however, is a beast. So it is really hard to learn and super confusing in the beginning. I'm really not a master in ggplot either. You could teach a whole class on ggplot. So it's really super complex, and yeah, but you will need it. So especially if you want to create professional academic graphics, and you use R, you need to use ggplot. So you won't get far with the other functions in most cases, right? I mean, if you just want to plot your so some means, right, and a bar plot with some error bars. You can get away with our base package, but so for anything that's a little bit more advanced, so you will need ggplot. Okay, so what ggplot does is it divides plots into different core components. Yeah, and these components are the data themselves. So that is, right, makes sense. so far, no complaints. Then it has a component that is called aesthetics, and that is super confusing because it's not actually really, so when we're talking about aesthetics, so we usually think about, so what is a color, right? So the width and the size of the elements of a plot. But in aesthetics and ggplot is a little bit different. So they are actually mapping. So it's a mapping function of the variables that you have in your data to certain aesthetic components of the plot. And it's really not always easy to wrap your mind around that. And then, so it has a component that is called geometries, which is, again, a little bit easier to understand. The geometries you can think about, it's not 100% true, but so you can think about it as different plot types. Yeah, so geometry might be, for example, a bar chart. Geometry might be a line plot. A geometry, so the geometric object might be a scatter plot. So it's just basically, right, so it's a visual object, so how you want to present the data and what kind of graph. And it have themes that change the overall appearance of your map. So it's like more like a superordinate category. So you can change, for example, your color palette, and right, so general collections of lines. And I think the hardest to grab aspect is the aesthetics component. All right. Okay. So so the ggplot2 package has basically one core function, and that's a function ggplot. So everything we're doing starts with ggplot. So that is basically otherwise we couldn't plot anything. And then ggplot, so we pass to ggplot our data argument. So we have to tell ggplot, so what is the data that we actually want to plot from? And so it's important to know that ggplot requires the data to be in a data frame where each column is a variable. So ggplot will not accept anything else. So you cannot plot from a vector. You have to make the vector into a tibble first, or data frame. Yeah? So otherwise ggplot will not plot that vector for you. Very important to keep in mind. Nothing but data frames. Everything has to be data frame. And I already mentioned that, right? When we talk about aesthetics, so normally we think of things like the color, the size, the shape. Yeah, but in ggplot, it's not simply about how things looks, but it's how we map variables in our data set onto visual properties, onto these aesthetics of our geometric objects. Yeah, and then again, the geometric objects are simply visual representations of our data. So the bar chart, the dot plot, a pie chart, etc. Okay, so first we start easy, right? So first, so again, we will do some initialization here. You should already have loaded ggplot and tidyverse, so you don't have to do that again. So we will work with the data Midwest that comes from ggplot. And so first of all, we basically tell ggplot, so please use data Midwest. So it's always the first argument, right? It's our data set. So please use this Midwest data set. And then, so, right, so this is the definition of the aesthetics. So it's a function AES, right? That's the aesthetics component. And so basically what we're saying here is please assign the variable area from the Midwest data set to the x-axis, and the variable pop total, that is the total population. So area are certain counties, and the pop total is a population. So the total population is these counties. So please map so that area, so the counties, which is categorical variable, to the x-axis, and map, so the variable total population to the y-axis. That's what we're doing here. And then what, so basically it's just initializing the plot. And then what ggplot is doing is it's very disappointing, right? So it just shows us, so our x and y axis with the variable names, but no graph. So what's going on here? Why is it not plotting anything? Yeah, because as I mentioned that already, so that we have to, there's this, there's a geometric object. So we have to tell ggplot first what we actually want to, whether we want a line chart, a bar chart, and scatter plot. So what we want to do, right? So without telling ggplot what we want to see, it won't do anything. Okay, so and that is a big difference to other plotting functions that, for example, that come with the base package. All right, so let's just make a very simple scatter plot. And the so the function that creates a scatter plot geometric object is called geom_point. So with geom_point, we are creating a scatter plot. So that is the function that creates a scatter plot. And if we are adding that to our basically this ggplot, so this initialized basic plot background, right? So then we'll see, yeah, now we have some data points. And you will see that, so we used this, so this plus operator here. And that is another special feature of ggplot that is a little bit unusual, that you have to get used to. So you can basically, it's like a little bit of an onion principle. So you build your plots like layer by layer or element by element. And you're just adding on additional elements or additional layers using this plus. Yeah, so whatever you add, so you basically, after defining your basically what data set to use and the default aesthetics, you're basically adding everything else as with a plus sign, all the other components. And you can think, so often it's referred to as a layer. So a layer always contains either geometric object or statistics. So again, it can be confusing. So just think about a layer as some, right? So some chart type. In this case, a scatter plot. And you can think of these layers a little bit like transparent, so like some plastic, what are they called? The plastic transparency, right? So each plastic transparency has something printed on it, and you put that, right, with each plus, you put another plastic transparency with something printed on it on your plot, some additional component, right? And then that's how you build your plot. So, okay, at least we have something that looks a little bit like a plot here. But so we still lack some basic components such as a title, meaningful axis labels. And also you see that most of the data points are really concentrated here in this lower area. So then we have this one outlier here, and so that's not very nice. So it does not give us a good representation of the data. So we will rectify these problems in the following steps. And as I said, so the geom_point, that is just one function to define a scatter plot. There are many, many, many so-called geoms. That's short for geometric objects in ggplot. And so we will have examples for each of them. Okay. And you can add, so for example, you can also, that's a nice thing, you can have a scatter plot and you can add a bar chart to it. You can fit a line, right? So a regression line. You can make a pie chart on top of it if you want to. You can have like 1 gazillion things in your, right? So you can just keep adding, so have everything in one plot. Okay, so we're starting simple. So what we're going to do next is we will add a regression line. Yeah, so we will basically just fit a line here, a linear function, so to our data set. And so this is another element, right? And it's just another geome, another geometric object, and it's called the geome smooth. And we always have to tell it what method to use. And here in this case, it's a regression, right? So regression line, so for a simple linear regression, and that's why the method is linear model. That's just short for linear model here. So we are adding this this fitted line here. And so what you can see is this dark gray, or the shaded gray area, is a confidence interval. So it's a confidence band for the position of this regression line. If you want to turn it off, you can do that as well. So you have to set the argument accordingly. 1 second, I think I have it in my, oh yeah, here. So you have to set SE, so the standard error, to false to turn off the confidence bands. Okay. And you can also change what you, so per default, it's the standard error, but you can change it to other values as well. Okay. All right. So as I said before, it's a little bit, it's not so nice that basically everything is so condensed down here, because we have this one huge outlier here with a massive population, right? So one county has a really large population. So that doesn't give us like a really good idea of what the data here look like, right? So because they're basically all lumped together. So there are two major ways you can control the limits or the range of your y-axis and the x-axis. Now they are fundamentally different in terms of what they're doing with a non-use data. So you can, so that's the first way, you can just delete points that are outside a certain range. Now you could say, well, I will just delete everything over 1 million here, right? So just everything that's more than 1 million. So these counties here, I will just delete those values from my data set, and then I will plot again. Now it's the first option. And so in order to do so, you can use the functions xlim and ylim. Yeah, so you need to pass the maximum minimum values for your axis to ggplot. So what we're doing here, right? So they're just very much the same way. So that is very straightforward, right? So we just add that with a plus as new elements to our plot. So, right, so we have defined here our plot, so our plot object as G, right? And we can just keep adding on to G. So that will just keep adding new elements to our plot, right? So, okay, so now we say, all right, so this element here defines what basically what's a desired range for our x-axis is. And so we want, to limit that to 0 to 0.1. And so I don't know why the area has a numeric value, but anyway, it's supposed to be counties. It doesn't matter for our purpose. And then, so we want to limit the y-axis or the population to 1 million. So we delete everything that is outside of that range. So it doesn't have any impact on the x-axis because there was no larger value and no value outside this range anyway, but it will have an impact on our y-axis. So if we do that, then we see so that, right? So we have like pulled apart these values here a little bit. Okay, we also see that the line of best fit so became more horizontal. Right, so compared to this original plot, so it's basically almost so no slope here, and that is because so we have deleted the points, right? We have deleted these outliers. So what actually called the slight slope here was just these huge outliers here. So that pulled the line upward. So now it's no longer the case. All right. Okay, so. We can also, the second method that we can use if you don't want to actually delete the values, which in many cases might be desirable, the second method is that we basically just zoom in. So instead of excluding so these outliers here, we basically ignore them, and we just basically have a zoom, and we say, okay, we're just zooming on this range here, but we don't touch these values. We're just zooming that here. We're zooming out this data range, or zooming into this this data range here. And in order to do so, we have to use a function that is called coord Cartesian. Yeah. So let's assume we are creating a new plot, G1. So we store that new plot in the variable G1. So and then again we add this new element to our existing plot G. And again we give it the limits for the x-axis and the y-axis. And then we plot the data again. And you can see now the line of best fit has this slope again. That is because we didn't actually delete these extreme values they're just right. They're just not visible. We're just zooming in into the figure. Yeah. So to see a little bit what the data here look like. So we can also add a plot title and labels for the x-axis and y-axis, and that can be done using a function called labs with title x and y as arguments, or you can use ggtitle, xlab, and ylab. Yeah, so different ways to do it, but same result. So if we wanted to add a title, we just say, okay, G1 plus labs, and when we give it the title, that is area versus population. You can also give it a subtitle. And then we define what is the axis label for our y-axis, what is the label for our x-axis. And so we also define a caption. Right? So that is called mid-fast demographics. All right, super. So right, we see here population, area, right? Then it's a title, subtitle. So, and we just add all these elements. So these additional labels and titles as a new element using the function labs, right, to our existing plot. This is a different way of doing it, right? So same result. We're just doing it separately. So here we're having different elements for title and then for the labels for x and y axis. Okay. So what we can also do is we can change the actual aesthetics. So in terms of how the plot looks like by modifying our geomes, right? So here, if we say, well, so these black dots, so I don't really like them. They're a little bit too small, and also I like blue much better. So it's my favorite color. So let's make the dots blue and big, and also this black or this blue so line here. I don't like that. I want it to be red. So then we can do that, right? So this is basically just putting all the commands that we have called separately here above in just basically one expression. Doesn't matter, right? Whether you do it sequentially or in one call. So. And now we're for the geome point. So for our scatter plot, we just say the color we want to be steel blue, yeah, and the size we want to be 3. I think the standard size is 0.5. So we want to make them bigger, and we want the dots to be blue. And then for our line of best fit, we want the color to be fire brick. Yeah. And so these are all system defined values. So basically you cannot make up your own. You have to use something that comes with the ggplot library. Right, and so then it looks like this. And you have to define that inside your geometric object. Right, so what you want to set it to. Okay, so and we can also basically set the we can also change the color based on right. So we have the different counties here, and so here the counties we don't differentiate between the counties, so we all basically treat them as a whole set, and so they have the same color. But let's say we wanted to divide actually the counties by state. right? So state is another variable on our data set. And we want to, for example, we want to see, is it Illinois, Indiana, Michigan, Ohio, right? So we want different colors for the different states, so counties or the area in the states. Then we can do so, right? So, and what we are doing here is we are, so in our scatter plot, right? So we are defining for the aesthetics, we are setting the color value to the variable state, and that will tell ggplot, right? So rather than defining a specific color like brick, fire brick, or steel blue, we're actually giving it a variable from the data frame, and that will tell R, so please print the dots in different colors based on the categories in this variable state. Yeah, so give each value, which is right, so it's Illinois, Indiana, Michigan, Ohio, Wisconsin, give each of these values a different color. And then it will look like that. So just to give you like an idea of what we can do. All right. So just one more comment, right? So if you, so you can use the, so when you define the basic ggplot, right, in the first step here, your basic plot, then you define the aesthetics, which in this case here is just the basically the mapping of a variable to the x-axis and a mapping of another variable to the y-axis. You could also do the following. So you could also map basically so your color aesthetics here in this first aesthetics call. So you basically could add the color, so the color equals state, so the assignment of state to color in this first function call. But what happens then is that, so this will be a global assignment. So that means that ggplot will try to assign that to all the elements that you define and add on later. Yeah, if it's not what you want, for example, if you wanted to plot a bar chart here as well, so then it would try to do the same. So it would also try to differentiate the colors by state. And if that's not what you want, then it's better to define it only if you say, okay, I only want different colors by states for my scatter plot. Then you have to define this aesthetic feature, so this mapping of state to the different colors only in your scatter plot geometric object. So that's also an important difference, right? Okay. Alrighty. So you can, and that is just something that I'm adding here. We will use it later. So you can not only use color, but also size, shape, stroke, that's the thickness of a boundary, of fill, so the fill color to discriminate groupings, right? So fill is typically used for bar chart, for bar plots. Yeah, or you could discriminate, for example, so that you could make different, if you would define, so the shape, right? So if you would assign state to shape, then you would have different shapes like a triangle or square, so for the different states. Okay. All right. So this is just so how you can set your color distribution. Not important right now. All right. So now that we have introduced some basic features of ggplot, let's talk about how we can plot the distribution of a single variable. In order to do so, we will in most cases use histogram, right? So there are other options, but histogram is our most basic plot. So the histogram just shows us a distribution, so the overall distribution of all our data. We're using our Midwest data here, but we are now only interested in the total population, right? So we are, and that what we are plotting on the x-axis. So we don't have a y, so we don't have an assignment to the y-axis here, because it's just a statistic here, right? So we are just plotting the count of the cases in the different categories here, right? So how many do we have in, so that have like 250,000, 500,000, 750,000, etc., etc. Okay, so that's why we have only one value here, right? So we're just defining the x, the assignment of the variable to the x-axis. And our geom here is called geom histogram. And so this function just automatically calculates an optimal bin width for us. So how basically over what interval of our total population values we're integrating, right? So to come up with a count, so how wide our basically bins are. Okay, and then we are also limiting our data range a little bit, right? So that we don't have like a super long, because we had this one outlier, right? So we are like a few outliers, 4 or 5, so we are limiting it to 1 million. All right, and that's what we are getting, right? So we're getting a histogram that shows us that, so we have a maximum here for relatively low population density. So there are like over 120 counties that are in this relatively low range. And then, so we have a few outliers here that have like a higher population. And instead of creating discrete bins, we can also compute and draw a kernel density estimate. So kernel is just not, so we don't have to, it's a little bit funny word, but just some smoothing function. So you don't have to worry about that right now. So it's basically an estimate of the density function, the probability density. Yeah, so it's a smooth, you can think of it as a smooth version of the histogram. Right, so it basically for a variable that comes from a continuous distribution, right? And because our data, of course, is always discrete, so R estimates the smooth probability density function, right, for our data set. And again, so it's a useful alternative for histograms that are made for continuous data that come from an underlying smooth distribution. Yeah, so if you have like a data set, a large data set that has, where you have a continuous variable, then it might make sense to plot your density. So your estimated density rather than showing a histogram. And so in order to do so, you use just a different geometric object. Now, you don't have histogram, then it's called geom density, right? And so again, we're doing the same limitations here. And so this is our estimated density, right? And it's basically just like a smooth version of this histogram. Right? So we're basically just letting the bin width go to 0. Okay, so we have already plotted plots for data sets or for two that show 2 variables. But so what I have here is basically, let me just give you a general idea what comes next, and so and then I will give you some guidance on what to focus on when you work through the remaining information here. So when we plot 2 variables, so again, we have different ways of displaying so the information. We can make it a bar chart, so where we have on the x-axis different, so a categorical variable, and on the y-axis, now let's, for example, numeric variable, and we can show this, so a plot, so that has, so in this case here, it's a highway mileage for different cars, so the fuel efficiency, and on the y-axis and on the x-axis we have the manufacturer, so who's a car maker. So we can also add like an additional variable, right? So if we want to differentiate by the year, so the car was made as well, so we can, right? So there's a different ways of plotting that. And so this is just to give an example what happens if you try to group the data visually based on some other variable. And you can create a panel display, or it's also called a faceted display of the data. You can make a line plot, right? You can make a scatter plot. We have talked about that already. You can split the scatter plot by different categories. And you can create a box plot, the violin plot for distribution, etc., etc. And this is about how to plot confidence intervals. What else do I have? I think that's it. Yeah. All right. So the question is, what do we want to do? Because we are at the end of our lab meeting today. So I could either stop here and you work through the remaining examples on your own. So I'm just moving along this tutorial. Or what I could do is I can just record myself and make another video of me talking while I'm going over the tutorial. So what is your preference? Do you want to hear me babbling, or do you want to work with it on your own? I mean, not now. I mean, we are stopping now, but do you want me to record some audio, or do you feel it's enough if you work with it on your own?
I don't know. I feel like I'm looking at it, and I remember doing it last time, and it was pretty direct. I don't know. Somebody else vote on it. I don't know.
Yeah. I mean, how about that? We can. So why don't you all go over the material, and then I can make another office. So I mean, I can basically offer another Zoom meeting, so virtual office hour, or like some extra meeting time this week, where you can ask questions. If you have if there was something that you didn't understand, or something that was unclear or confusing, and then we can just have like a question answer session, so on specific aspects that. And there's one more as a sampling. It's relatively short though, the sampling, but it introduces something that you need for the assignment. So the different basically the different distributions and how to basically sample from a normal distribution, which might be important. And I also want you to understand that, right? So how to do that in R. That's why I thought it might be good to have like another, at least the option for you to ask questions if there were things unclear. Does that sound reasonable?
Yeah, that sounds okay.
Alrighty. So yeah, any objections? Okay, so then I'll send you an email. We will probably, is there a day that works generally better for you? So is it like Friday, Thursday, or is it too late to the for the assignment? So maybe Thursday. And then, so for me, typically later in the day works best. So is that something that also works for you, or rather not? Yeah, so how about Thursday? What is a good time on Thursday for you guys? I mean, it's not mandatory, right? It's just, I basically just want to offer those of you who have questions or would like to talk a time window where we can go over some open questions and things that were not clear.
Maybe like the same start time as this. So like you said afternoon, so like 5.
5. Yeah,
that's 5 for like an hour, whatever.
Sorry, I couldn't. It's 5.
Yeah, I was just saying that 5 works for
I
me.
think that's a good idea.
All right, so sounds good. Then, so everything is on Blackboard already. So then I would say work with they're pretty detailed, so the tutorials, and so I try to add explanations. So and then so on Thursday we meet at 5, and then we can discuss everything that is unclear and that you still need to understand to complete the assignment, or that absolutely doesn't make sense to you. Yeah? Okay, super. All right. You can also, I mean, that is another option, right? I have my office hour tomorrow after class anyway. So if you're fast enough or have already a lot of questions from today's session, you can also just stick around. So I mean, I will just stay online after class tomorrow, and you can ask a number of questions that already that you have right now, and before you have a chance to actually look at it. Yeah. Okay. Good. Super. Then thanks for your attention. I know it's a lot. I know it's really hard. I understand that. But again, so it's really, really a really important skill for you guys to learn that. And it's, as I said before, learning to program is hard. It is exhausting and can be super frustrating, but it's worth the effort. I promise. All right, and I hate it. So I just want to. I know. So I'm putting a lot of stuff in the different meetings, and I know it can be overwhelming. So let me know if you feel it's too, that you're really super overburdened, that you just work for our class and have no time for all other classes anymore. But I'm just trying to make sure that you get all the tools that you need. Yeah. Okay. Alrighty. Then I'll see you tomorrow. And have a good night.
Good night.
Bye.
Good night.
Bye, thanks.
Right.